In this video, I'm going to talk about three different technologies for first hop redundancy protocol. HSRP and GLBP are Cisco specific. Also VRRP is there, which is super similar to HSRP, and it is a standard version. So if you have Cisco routers, then you can go with HSRP. If you have newer Cisco routers, which has something like iOS, I believe 12.4 and up, you can use GLBP as well. Also, VRRP can be configured on different vendors' routers. Before continuing, I would like to ask you to subscribe to my channel. Also, click on the thumbs up. This is going to motivate me to create more of these kind of videos for you. Also, there's a bell notification. If you click on that, you will be notified as soon as I post a new video. Now, let's start the configuration. I'm not going to go to the details of all the commands. I'm just going to enable these on the routers, and then I'm going to show you some verification command. In the end, I'm going to get to Gateway Load Balancing Protocol, or GLBP, which is, like I said, the best one. The difference between GLBP and VRRP and HSRP is GLBP at the same time can have multiple routers as active nodes, but VRRP and HSRP can have only one of the routers as active node. How can we use all the routers as active nodes in HSRP and VRRP? As a matter of fact, we can configure multiple groups on them, and each group can be active for some series of VLANs or a specific VLAN. That is how we just use all the nodes in HSRP and VRRP. In that case, we just call it multiple HSRP or MHSRP or something like that. I'm not so sure about it, but let's go to the configuration. This is going to be a pure configuration course, so let's go to the configuration. So let's start from router 1. I'm going to enable HSRP. On router 1, first of all, I'm going to show you interfaces that I have. You see that this interface is configured for the inside LAN, and this is router 3. As a matter of fact, router 1 has the same thing. It has an interface in the range of 10.10.123.0/24, and that is going to be the one which I'm going to configure for HSRP. Before doing this, let's go to the PC, and I'm going to show you the PC configuration. If I type show IP on this virtual PC, you can see that it has an IP address in the range of 10.10.123, and its gateway is router 1. If router 1 fails for some reason, this is not going to be able to get to the internet. Right now, of course, the internet is available. You see that this is a prefix on the internet, and it is pingable. That is because router 1 is working just fine. Now, we need to make sure that router 1 has redundant other nodes, so that if it fails for some reason, the others are going to take over the role. So let's go to router 1, and I'm going to go to configuration and go to Ethernet 00. The first thing that I'm going to enable is HSRP, which is a Cisco specific first hop redundancy protocol. So it starts with standby command. Standby needs a group number. Like I said, I can have multiple group numbers. You can see that I can have 256 different groups. I'm going to start with number 1. Then I'm going to assign an IP address to this. This IP address, as a matter of fact, is a virtual IP address, which means that multiple routers are going to share this IP address. And this is the one that we are going to configure on the DHCP, so that DHCP is going to, kind of broadcast this to its clients. Rather, devices are going to receive this IP address. They don't know this is virtual. They just think that this is the way out of the network. So that's going to be 10.10.123, let's say 254. Okay, hit enter. This command is going to be enough, but if I want to have some other features, I can add more commands. For example, I can make sure that preemption is enabled. By default, preemption is not enabled. So what is preemption? Let's say that router 1 and router 2 are in the same group. Router 1 is going to be active, router 2 is going to be passive, or let's say in standby mode. If router 1 fails, router 2 is going to take over the role. It is going to route for the network. But if router 1 comes up later, router 1 can redeem its role, and it can say that I want to become the active router router again. By default, preemption is disabled, and I'm going to show you how. But let's say that I'm going to say standby 1 and preempt. Hit enter. Also, there is a priority value here. Priority says that I am going to be a better candidate than you, and the higher the priority, of course, the higher the chance of this router to be elected as the active node. So I'm going to say that priority is something higher than 100, which is the default one. So let's say that 120. So this is going to have the priority of 120. Okay, let's go and do the same thing on router 2. By the way, you can see that right now this router has started the HSRP, and it is in active mode here. So let's go to router 2. I'm going to go to here. I'm going to go to interface Ethernet 00. The same commands that I have here, with a little difference, of course. Standby IP address should be the same, because we are talking about a virtual IP address which all the routers are going to share. Then I can have a priority. Let's say that, for example, priority is going to be something like 100. Preemption is not so necessary because I already know that router 1 is going to take the role, and here I'm not going to have any chance because my priority is 100 by default and router 1's is 120. So now that I have done this, I need to go to PCs, and I need to tell them that your IP address is going to be now something else. 10.10.123.201/24. Now the gateway is going to be 10.10.123.10.10.123.254 instead of 1. Now that I have assigned this, PC of course doesn't know that this is a virtual IP address. It says that this is the way out, so PC is not going to feel any difference. But let's see what happens. PC is going to try the ping one more time. The ping is successful. Now let's say that router 1's interface or itself goes down. So you see that after it goes down here, this is going to be active as soon as possible. You can just say that the role is going to take something like 3 seconds to take the role over, but you see that here it is almost instantaneous. So PC, does it know anything about this? No, it doesn't understand anything, because we have a virtual IP address and that is the one that we have assigned. Now if router 1 now comes back to service, you can see that because we have enabled preemption, this is going to redeem the role as soon as possible. So wait for that. It has higher priority, also it has preemption. So we should see that here it will say now I am active. If I go to router 2, of course, it says that now I am standby. Router 1 here, yes, before even I just see that it went active. So this is how you configure standby. Now I'm going to delete this standby HSRP. I'm going to go with VRRP. And before doing that, let's say show standby is going to give us information about what we have here. It says that preemption is enabled because we did that, of course. It has a priority of 120. This is exactly what we did again. And it has a state of active. If I do the same thing on router 2, show standby, it's going to say that priority is 100, which is the default, of course. Preemption is disabled by default because we didn't do anything on router 2 to enable preemption. And I am in a standby mode right now. Virtual IP address, of course, is this. And for this virtual IP address, we are going to have a virtual MAC address. We can set it manually, or we can just go with the default here. So as soon as the device starts ARPing, it is going to receive this virtual MAC address, and this is for all the routers, not just for this or router 1. Exactly like the IP address that we have here. This is for all the routers. Okay, let's disable this. So I'm going to type no standby 1 on both of the routers. No standby 1. Now I'm going to enable VRRP. Like I said, VRRP configuration is quite the same as HSRP. So instead of typing a standby, what I'm going to type is VRRP. And again, it asks me for group number, let's say for example 1, and then it can have an IP address of, let's say 10.10.123.255. Hit enter. It can have priority again, it can have preemption again. So if I just show VRRP instead of show standby, you see, you can just type show VRRP, it will tell you what the situation is. Here it says the IP address cannot equal interface broadcast address. Okay, so I just made a mistake in configuring this. Instead of 254, I just typed 255. Now you see that it says I am in backup mode, but after some time it is going to go into master mode. So the difference between this and HSRP is in the messages as well. We have active and standby in HSRP. We have backup and master in VRRP. I'm not going to configure the other one. I'm just going to show VRRP to see what we have here. Again, there is a virtual MAC address, there is a virtual IP address, and the important thing is preemption is by default enabled. In HSRP, preemption was not enabled by default. Also, the priority is by default 100. Okay, we can do the same thing again on router 2, and this is going to be again the address that we assign to other devices using DHCP or some other mechanism, doesn't really matter. What I'm going to show you is this. When we have HSRP or VRRP, only one of the devices are enabled, the other one is not enabled. Like I say, we can have multiple groups, but the active router is just going to be one of them. The rest of the routers are going to sit there and wait. If the first one fails, they are going to take the role. Well, let's go for GLBP. That is again something that I'm going to create here. VRRP1 is going to be disabled. Now let's go for GLBP. I'm going to start the configuration with GLBP. Here you see that again we have a group number, and then it says that what is the IP address for that. That's going to be 10.10.123.254. And then I can have some other configurations such as preemption, and this is, I believe, that disabled. I'm going to show it in a second. Priority can be set here, but something which is very important is waiting. Here we can say that we have multiple active routers. So one of them is going to be, let's say for example, more powerful than the others, or it has a higher bandwidth than the others, so it can take more of the requests. So what happens when we have GLBP? When we have GLBP, let me show you this. When we have GLBP, the device is going to send an ARP, right? One of the routers is going to be the active gateway. Let's say that router 1 is going to be active gateway, okay? What does active gateway do? Active gateway responds to the ARPs, right? So let's say that PC1 is sending an ARP. Active gateway is going to give the MAC address of router 1, for example, to this one. If there is a PC2 here and it sends an ARP to active gateway is going to respond with the MAC address of router 2 maybe. And the third PC, of course, is going to receive the MAC address of router 3. Now, if I set the weight higher on router 3, let's say that, for example, the weight is going to be 100 on this, 50 on this, and 50 on this, this means that router 3 is 2 times more powerful than router 1 or router 2, which means that for any request that I send to router 1 or router 2, I'm going to send 2 requests to router 3. That is because of the weight that I am setting here. So this is the difference between GLBP and HSRP. Another difference, as a matter of fact, because like I said, all of the routers are active here. None of them is going to be in a standby mode. So I'm going to say that this is a strong router. So let's say that GLBP waiting is going to be something like, I'm going to say 100, for example, for this, or let's say, for example, 150. That is better. Also, let's say show GLBP. it says that priority now is 100, that I didn't change of course, but the weighting is 150. What is about preemption? Preemption is not there by default. But this is not so important, because one of them is just going to be the active gateway. That is the router which is going to respond to the ARP messages here. And in my case, you can see that it says forwarded 1 is active. This is going to show that the active gateway is this one. And state is active and everything about that. So let's go and configure this on other routers. So far, show run interface Ethernet 00. This is the configuration that I have. And I'm going to go with this part. So let's go to router 2. I'm going to say that the weighting for this is 100. And let's go to router 3. I'm doing this on router 3 as well. So I just go to configuration mode and interface Ethernet 00. It's going to have a weighting of, let's say, 100 as well. So router 1 is the strongest one. Router 2 and router 3 are just normal. So you see that here it says I am active. Router 3 after some time is going to say that I am active as well. Here. You see that all of them are in active mode. Router 1 active, router 2, router 3 active. So let's check this. Do show GLBP. Here it says that I am forwarder 3. As a matter of fact, this is forwarder 3. Forwarder 2 is going to be router 2. Forwarder 1 is going to be router 1. Okay? I have weighting of 100 here. Preemption, I didn't set preemption on none of the routers as a matter of fact. This is the virtual IP address that I have. So what other information is important here? We have the group members, the actual IP addresses, also the MAC addresses, and you can see that this one says that I am this. From this tree, I am this. Okay. And let's go to router 1, and I'm going to, and here it says active is this one. This is the primary. You see that? This says that the actual gateway, active gateway, is going to be router 1, and the rest of them, of course, are just forwarders. They are not going to respond to the MAC addresses. So if just one of them goes down, let's say for example router 1 goes down, let's see what happens. So router 3, I'm going to execute this command one more time. Here it says that forwarder 1, here, one more time. So it says that one of the forwarders now is down. It doesn't, have any information. So let's see which one. See here it says that forwarder 1 is active, forwarder 2 is listening, forwarder 3 is active. One more time, let's see. Forwarder 2 is just listening. We are just waiting to see what is happening, right? Forwarder 1 is active, forwarder 3 is active. So which one is going to be the primary? This is the primary. See that? And the actual IP address is 10.10.123.2. This is going to be router 2. So this is the primary one. Responding to the ARP messages. What happens to PCs? PCs, of course, don't do anything. So if just go here and say no shot, again, this is going to go up, and again, PC doesn't understand anything. So for PCs, for devices in the network that is not unknown, it is not, this is totally transparent. So they are not going to understand anything about this. So, like I said, which one is the best one? GLBP is good in that all of the routers are active at the same time, but we can have, of course, multiple HSRP and multiple VRRP. So that's it for now. I'm going to explain some other concepts later. Just comment and tell me what you want to learn, and I'm going to teach that for you.